I hope you're having a wonderful day so far, and I want to make it even better by starting off with some math practice. So let's go ahead and take a look at our four warm-up problems for today. And we have our first problem, which is a word problem, and it says, Isabel wants to cut string to make bracelets. She has 21 inches of string. So that's one length of string, and it says how many 7-inch pieces of string can she make? So if we recognize here, we have 21 inches of string. That's total string in length, and we're cutting it into parts or pieces that are 7 inches long. So do we have 7 groups of 21? No. What we're doing is, if you imagine, we're taking that string and we're cutting it into parts, so we're dividing it. So what we're going to do is take this 21 inches and we're going to break it up evenly, or divide it, or share it equally into 7-inch parts. So this is how many inches are in each group or each string. And this is all the string. This is total string length. And we want to know how many groups or how many pieces, the pieces are the groups, we are going to be able to make. So if I had, and I'm going to just use what I know about division back here in the back, and I'm going to say, okay, here's one piece of string, and that string is 7 inches long. Okay, so that's 7. Now I have another piece of string, and that piece of string is also 7 inches long. Now, so far, we have 7 and 7, which makes 14. So that's not the 21 pieces in length yet. And then I'm going to draw another piece of string, and I'm going to label that 7 inches to kind of help me visualize what's happening here. And now I have 7, 7, and 7. So I have 3 groups of 7, and that gives me, right, 21. So when I take 21 inches of string, okay, and I'm just going to show this as all 21 inches, right? This is the 21 inches of string. When I take that 21 inches of string and I partition it or group it into 7 equal groups, I ended up with 3 pieces of string. So I have my model here. I have my equation, which is 21 divided by 7 equals 3. And now I can say, Isabel will be able to make or cut, let's say cut, 3 pieces of string because I divide 21 into groups of, or cuts of, 7 inches. So 21 divided by 7 equals 3. And there is my response. So if your response sounds similar to this, that's great. Keep on practicing writing your responses so that we can imagine your thinking, and when it says to explain, you can do a very good job of explaining what you need to. All right, let's go ahead and take a look at our next problem. It's a subtraction problem, and we are going to take this 967, which is our total. It could be 967 balloons, 967 pickles, 967 of anything we can possibly think of. But we have a total number that we know of. And part of that, some of that, is going to be part of this 967. We want to find out what the other part is when we add this amount to this amount to bring up our total. So basically what we know is we have 794, which is part of that. We don't know the other part because that's what we're looking for, but when we add them together, they should come up to be 967. So we're going to take and use our subtraction, and I'm going to first use my algorithm. So I'm going to go ahead and line up my place values at this point in time. And I'm going to start in my ones place, and the reason we start in our ones place is just in case we need to borrow or regroup. So in our ones place, I have 7 minus 4, and I know that I can subtract this 4 from the 7 because that is enough to subtract 4 from the 7. So remember, you can always use addition to help you find what could you add to 4 to make 7. So if you said 3, that would be correct. So we didn't have to borrow because there wasn't a reason to. Now let's take a look at our tens place. We have 90, and from that we're trying to subtract it from the 60. And so that tells us we have more than what we have to start with. And so in this tens place, I'm going to have to use one of my hundreds to help me use that to subtract. And I'm going to use one of those hundreds, and I'm going to regroup it as 10 tens. And now I'm going to have 16 tens, which is 160. 160 makes 16 tens because 10 tens is 100. Now I'm going to subtract those 9 tens from these 16 tens. Now I have enough to subtract. And if we know 9 plus 9 is 18, well, this could not be 9 because that's too many tens. So what about 8 plus 9? That would give me 17. So one more less, excuse me, is going to be 70. 7 tens is going to be 70, and now I can subtract my 8 hundreds from and 7 hundreds, and that gives me one more 100. So my difference is going to be my difference. Remember, that's the answer to a subtraction problem, difference. We are going to see that this missing part of this 967, when I take 794 from that, is going to be 173. Now, I could also do it by using place value, and I'm going to start with my hundreds place. So 900 minus 700 is 200. And later on, I might have to regroup. So we're going to see and check. We have 60 minus 90. And yep, sure enough, we had to regroup. We had to regroup 100. And when we regroup 100, we're adding that 100 to the 160. And so we have 16 tens. And now I'm going to subtract. So to get to 100, I would need one more 10. And then from 100 to 60 is going to be 60. So 60 and 10 more is that 70 that we were thinking about earlier. And finally, I have to regroup, I have to subtract 7 minus 4, 7 minus 4, and that gives me a difference of 3. And now I'm going to put my place values back together. 100 plus 70 plus 3 is going to be put back as 173. So now we've done our subtraction equation, our number sentence, and we get a difference of 173. And again, remember, you can always check using addition. All right, let's go ahead and take a look at our next problem, which is a bar graph. And you'll notice it's going by a scale of ones here. And it says favorite pets. And this is telling us the number of votes for this scale. And we have a gerbil, the G and the E make a J sound, gerbil, goldfish, iguana. So, how many children voted in all? So, how many kids voted for gerbil as their favorite pet? Right, 4. How many students voted for goldfish as their favorite pet? Right, 3. And finally, how many people chose the iguana? Yeah, for iguana, only 1. So now, how many students or children voted in all? That's the key phrase there. How many children voted in all? Voted in all. So we got 4 votes here, and 3 votes here, and 1 vote here. So fairly easy to write an equation for this. Please do so if you haven't. 3 and 1 makes 4, and 4 and 4 makes 8. Or if you want to think about it as 4 and 3 is 7, and then 1 more is 8, you could also do it that way in your mind. So we had 8 children that voted for the iguana. Now, the discussion question for today is going to be based on looking at our bar graph. So today I want you to take a look at how many more students voted for gerbil than iguana. Notice my question says, how many more children voted for gerbil than iguana? So think about that problem. Please also make sure to write an equation to prove your thought, okay? Show me an equation to show your work, okay? Now it says Brittany parks her car at 3:30. She puts enough money in the parking meter to go to the mall for 60 minutes. What time should she be back at her car? Now, if you remember, 60 minutes is an hour. And remember what happens on a clock when you have 1 hour that has gone by. Well, I have my handy dandy clock here, and I'm going to show what it looks like at 3:30. So here's 3:30 on our clock, and you'll notice that the hour hand is between the 3 and the 4, and the minute hand is pointing directly at the 6. That is 3:30. Now, remember, 1 hour is 1 complete turn of the minute hand around the clock. So we start here at the 30 and we end here at the 30. So when I add 1 complete hour, this would be half an hour, which would be 4 o'clock. Now I need to go another 30 minutes, and 1 complete turn of the clock is going to put me at 4:30. So the time that this should be would be 4:30. Now, if I were going to show this on a timeline, which I could do 6 groups of 10, right? Or I could do 4 groups of 15, because that's what it looks like whenever we break up our clock into 4 equal groups, right? 15s, right? 15, 15, 15, 15. I could do 4 leaps of 15, or I can just do 1 full hour to make this 4:30. So I could put this into 4 equal pieces. This would be 4 o'clock in the middle of that. This would be 3:45, sorry, 3:45. This would be 4:15, and finally 4:30. Or again, like I said, you could do 6 groups of 10. but several ways to kind of take a look at that on a timeline. All right, that's it for today. And don't forget to do your discussion question. Again, the discussion question was, how many more students voted for gerbil than iguana? So look at that bar graph and answer with an equation in your discussion. Have a great day and see you soon.